All right, so let's talk about probability. We're looking at independent and dependent today. Let me work questions 19 through 26. So there's two things. Let me write the words down. I just said it, that we're working on dependent. Let me write this thing out. Dependent. And we're also working on independent. Dependent. All right. What do they mean? Okay, so I'm gonna do two events, right? In probability, we call those events. Dependent means that the outcome on the first event affects the outcome of the second event. That's dependent. Now, independent means that the outcome of the first event does not affect the outcome of the second event. Not only we have to consider both cases, but we're going to have to deal with the probability. Probability, as a matter of fact, is going to be a fraction. It's a fraction that we change it to decimals between 0 and 1. So let's see. So you select a card from a standard shuffle deck of 52 cards. You return the card. This is a big thing here. So let me highlight it. You return the card. Shuffle and then select another card. Both times the card is a diamond. Note that 13 of the 52 cards are diamonds. All right, so I have the cards and I pull a diamond, right? My first event, I get a diamond. There's 13 out of 52, so I'm just going to say it. All right, 13 over 52. So that's my outcome of the first event, right? I got a diamond out of 52 cards. Now I return the card. I return it. So the whatever happened on the first event does not affect the second event. So that's what we called independent. All right, in the second event, I'm going to grab a diamond as well. We know there's 13 out of 52 on the second event. If I did not return the card on the second event, it will be 12 out of 51, right? There will be only 12 diamonds. There will only be 51 total. But because it is independent, because I returned the card. Now, let me just multiply this out. We can multiply it. I know multiplication, we can just multiply across. 13 times 13, use a calculator if you need to. That's 169. 52 times 52 at the bottom, that is 2,704. When I simplify this, let me divide each by 169. When I simplify this, it is 1 over 16. Some of you might be like, really? Am I going to have to simplify big numbers? Well, you can always simplify first. 13 over 52 is 1 over 4. I would simplify first. 13 over 52 is 1 over 4. When I multiply across is 1/16. So again, you can always simplify first. All right, let's take a look at number 20. You flip a coin twice. The first flip lands tails up, and the second flip lands tails up. So my first time, flip a coin and I get tails. So I'm going to say that is 1 over 2, right? There's 1 tails, and there's 2 choices, heads or tails. This is independent because it doesn't matter what happened to the first flip. It's not going to affect the second flip. Now, the second flip also lands tails up, so that's also 1/2. What's the probability of that happening? I'm going to say it's 1 over 4. Right. Don't forget, we can always change this to decimals, right? 1 over 4 is 1 divided by 4. All right, let's take a look at number 21. There are 6 nickels, 8 dimes in your pocket. So let me just write 6N for 6 nickels and 8D for 8 dimes in your pocket. So I have 14 coins. You randomly pick a coin out of your pocket and place it on the counter. Then you randomly pick another coin. So I did not replace the coin. So, okay, so here it says the first coin is a nickel and the second coin is a dime. So I have 6 nickels out of 14 total. I place the coin on a counter. So then I have 5 nickels now and 8 dimes. Now my second try, I'm gonna get a dime. So I'm gonna say 8 over 13, right? Because I have 8 dimes out of 13. Notice how the outcome of the first one did affect the outcome of the second one. That is what we call dependent. Okay, so we can always simplify, or you can just multiply 48 over 182. Once you simplify, this simplifies to 24 over 91. Simplify before you multiplied, or multiplied and then simplify. All right, let's take a look at number 22. There are 5 boys and 8 girls in a class. So let me just write 5 boys and 8 girls. The teacher randomly selects one student to answer a question. Later, the teacher randomly selects a different student to answer another question. All right, the first student is a boy and the second student is a girl. So the first student is a boy. So I'm just going to say, well, to begin with, there's 5 boys out of 13 people. That was the first choice. And the second choice, I'm going to say there's 4 boys and 8 girls, right? Because he chooses a different student. Okay, the second person reading the question here, the second student is a girl. So I'm going to say there's 8 girls out of 12. Okay, the outcome of the first one did affect the second one, so this is dependent. I can just multiply it straight, so that gives me 40 over 156. And when I simplify this, it simplifies to 10 over 39. Again, simplify before you multiply, or multiply before you simplify. It's up to you. Let's take a look at number 23. There are 7 nickels and 7 dimes in your pocket. So 7 nickels, 7 dimes. You randomly pick a coin out of your pocket and then you return it to your pocket. Then you randomly pick another coin. So, okay, so let's take a look. Both times the coin is a nickel. So the first time I can get 7 nickels out of 14 coins. But then I return it to your pocket. So the second time, there's 7 nickels, 7 dimes again, because I return my initial coin. Okay, the chance of me getting a nickel again is 7 out of 14. Multiply this out, I get 49 over 196. When I simplify this, it should simplify to 1 over 4. Question number 24. There are 14 shirts in your closet. There's 7 blue and 7 green. Okay, so let me do 7 blue, 7 green. You randomly select one to wear on Monday and then a different one on Tuesday. You wear blue shirts both days. So on Monday, I'm going to say there's 7 blue shirts out of 14. But I have to choose a different one on Tuesday. So for Monday, there were 7 blue, 7 green. For Tuesday, I'm going to say there's 6 blue and 7 green because I choose a different one. Okay, so on Tuesday, I have to wear a blue shirt as well. There's 6 out of 13. When I multiply this out, I get 42 over 182, which simplifies. Let me divide each by 14. This is going to simplify to 3 over 13. Now let's take a look in symbols. When my events are independent, the probability of both events, when I multiply them, is going to be the probability of both of them happening. So when we use the word and, we multiply. So I have to go for probability of A, times probability of B. This is equal to probability of A and B. Okay, so I have that 1/2 times 9/20. It's equal to, there's a question mark. Back in algebra, we learned that when we don't know the value of something, we replace it with the letter. In this case, let me replace it with X, and I'm gonna solve for X. Multiplication, we just multiply it straight. So I have that 9/40, it's equal to X. So there you go, 9/40. That happens when they are independent. Just probability of A times probability of B. Now, let's take a look at this one. Probability of A. Now here we have this notation here, this probability of B given A. So the probability of B happening given the probability of A happened. So I'm going to go probability of A times probability of B given that A happened is probability of A and B. Let me replace the values that I have. I have 7/20 times X. I don't know what probability of B happening A. So I'm going to replace it with a letter. And this is equal to 63/400. Okay, gotta solve for X. So let me divide by 7/20, or we also say, let me multiply both sides by 20/7. Remember, when we divide by a fraction, we multiply by the reciprocal. So I just flipped it. Okay, I can cross multiply. I can multiply straight. Let me simplify first. I don't want to go 63 times 20 and then 400 times 7. I can simplify 63 and 7 diagonally. Let me divide each by 7. So that gives me 9 and 1. 20 and 400, let me divide each by 20. So that gives me 1 and 20. Now when I multiply straight, I get 9/20. Let me zoom out so you guys can see what we did. Here you go.